All right, students, we're going to do the same thing as yesterday, just get better at it. All right, so we have the circumference, which we can describe as the circumference can equal c. Sometimes the circumference is described as pi times diameter, or 2 pi r. All right, and again, circumference, pi times diameter, 2 pi r, they all describe the same thing, and we got to make sure we understand that just for reasons. All right, so we're going to find the radius of a circle with circumference of 18 inches. All right, so usually it's like, okay, I'm finding the radius, so I'm going to use the one with the radius. All right, I'm going to use circumference equals 2 pi r. All right, and 18 is the circumference, 2 pi r. Now remember, if you're extremely close up, this is all multiplication. It's 2 times pi times r. So how do we undo multiplication? Divide. Duh. Now, something we have to be good at is using a calculator. When you do division of more than two things, you have to make sure you put it in parentheses. Your calculator's not very smart. If you do really fast, if you do like 18/2 pi, your calculator's pretty dumb. It's going to interpret this as 18 divided by 2, then times pi. All right, bad. All right, you have to incorporate these parentheses when you plug it into your calculators. All right, 18 divided by 2. Oops, I almost made this mistake. I said not to. Oops. It's about 2.9. All right. Find the exact circumference of a circle with diameter of 2.5. All right. Oops. I misspelled diameter. That's super embarrassing. There's supposed to be an A in there. Diameter. All right. The exact circumference with the diameter of 2.5. All right. So on this one, I'm going to use pi d. All right. And it's just literally going to be 2.5 pi. All right. That's the most exact. This is no rounding. All right. No rounding, no estimations, exact. All right. And then we got this one right here. Square PQRS is inscribed in a circle T. All right. So we got a circle and we got a square inside the circle. Let me see how good I can do this. Ugh. Not horrible, but not my best work. All right. So P, Q, S, R. All right. Now, something it's telling me is that RS is 8 radical 2. All right. So let's find the radius of circle T. So some ways we have to go about this. So yeah, that's T. All right. First, let's find this whole diagonal. All right. All right, let's find the diameter. Now, I just made a right triangle and realized that this is also 8 radical 2. So using properties of special rights, let's say RQ is 8 radical 2 times radical 2. Remember, then we do radical 2 times radical 2, and we get 8 radical 4. And then something we struggle with. Radical 4 simplifies to regular 2. So it's 16. All right. Whew, that was a lot of math. All right. So we found out this whole diagonal was 16. All right. So the radius then is just 8. All right. Oh, and we already found the diagonal, which was 16, which was the diameter. So then I can find the circumference of circle T. I'll make an arrow over here. Actually, I don't even need to. It just, we know the diameter, so it's just 16 pi. All right, pi times diameter, 16 pi. And then the perimeter of the square, 8 radical 2 plus 8 radical 2 plus 8 radical 2 plus 8 radical 2, which can be simplified as 32 radical 2. It's kind of just like adding like terms together. If you had 8x plus 8x plus 8x plus 8x, so on and so forth. All right. So just some circumference problems, some squares, special rights, all kinds of fun stuff. So now let's do a quick review. And this will be the last problem of this video. Is let's write down our bread and butter equation. All right. This is something that we're going to be using a lot. Central angle over 360 equals arc length over, now it's typically written as 2 pi r, but realize I can also write this as pi times diameter, or I can even write this as c. All right, those are all the circumference. All right, so this is what we're going to be using a lot. All right, and then in fact, next section we're using something very similar. So we're going to find the exact length of arc PQ in the figure to the right. So we're going to set up a parts of the proportion over the holes. So remember, that's what we just did, but I'm going to say this again. Central angle is part of 360. All right, central angle is a part of 360, and then the arc length is a part of the circumference, which is 2 pi r. All right, so it's a part over the whole. In this case right here, it's going to be 60 over 360. And then I get lazy and call arc length x because that's what we're solving for, 2 pi 9. And then something we're going to be good at is simplifying. 60 goes into 360 6 times. So this is actually nice, slick and easy, 1/6. And then 2 times 9 is 18 pi. And then from here, all you got to do is cross multiply. 6x equals 18 pi. Divide both sides by 6. And x equals 3 pi. Smiley